in our calculators, we push stat. So if you can all enter this in, please. And enter. And then let's enter in our data. So 1, 2, 3, 4, 5, 6, 7. So this is years after 2005. And then we have deer population. 60, 282, 307, and 336, 360. Okay? When you're writing your diploma, make sure to double check that you entered in your data correctly, right? Take your time, double check it. The worst thing is, Daniel, can you get that out of your... It's okay. Just make sure you double check it. The worst thing is you type one number wrong, everything's wrong, right? Okay, so what do we do next? What kind of regression do they want us to do? Read on. An exponential regression. So we're going to have to do an exponential regression. So what do we push again? It's number 0, yes, stat. And then calc. And you can scroll through, but it is 0. Don't push enter right away. What do we push next? Vars over to y vars function, so enter, and y1 enter. Okay, that's to automatically put our equation into our graph. They're going to ask you some question about it, so automatically just do that. Okay, so that gives us a regression. So y equals a times b to the power of x. I'll write this down. Now, in an exponential graph, what does the a value stand for? 200. Yeah? That's because your diagnostic's not turned on. So how do we turn on the diagnostics if you want to turn on? You go second, and then go to catalog, and then scroll down to diagnostic on. So you could also just push the D button right here, send catalog D, and then go to diagnostic on, and push enter, and then enter again. Okay. And then if you actually just go second enter twice, and you can go back to this guy, and it'll have your R-squared values. Okay. All right, and our V value is 1.088. 8 to the power of x. Does anyone remember what the a value stands for? In y equals a times b to the power of x. An exponential function. Steph? Beautiful. So your a is your y-intercept, or your initial amount. Okay, so the a is the y-intercept, or the initial amount, when x is 0. Okay, assuming that the same growth rate, predict the deer population 10 years after 2005. So what did they give us, an x or a y? An x. They gave us the x value 10 years after. Predict the deer population 10 years after. That's the x value. So now that we have our graph, now, one thing we actually haven't looked at our graph yet. How do we make it nice with our data? Automatically, without having to do work with our windows. Zoom 9. Zoom, and it's stat. Zoom stat. Zoom 9. Okay. Now we can expand our windows if we want to see a bigger picture of this. If we need to, we might have to zoom out anyways. But we try and enter in a value. How could I enter a value of x equals 10? Second trace, number 1 and 10. Now, what do you do if you get this? Zoom out or change your windows. If you go to your windows, you can see I'm only gone to 7.6 for an x value, and we want to go beyond at least 10. So you could go ahead and just change this and see if that helps. Now, you might have to go higher, like change your y as well. Another easy way is just zoom out. Zoom out will work, and or you can play with your windows. So I might change my min y to 0, max to maybe 500. Scale, that's ridiculous. Okay, zoom out works just as good. I like making pretty windows. because I don't get out much. So, yeah. Okay, so second trace 1, try that again. 10, enter. You zoomed out to the nearest deer. What is it to the nearest deer? 468. It's nice that the deer are growing. Now in real life, it might grow, but if things come to a surplus, is it always going to grow exponentially? No. Like it gets a point where food is going to run out for the deer, right? Which leads to not as many deer because they die and starve. So naturally, yes, it might begin out, in real life though, it might begin out as an exponential, but it won't maintain that for population. Because then what happens is something like this. You might have something happen in the deer population, that might start to grow again exponentially. All right.
Can I speak around and hand out Jasper reflection forms?
Absolutely. Okay, in which year? In which year? So what are they asking about? In which year? What value is that? X or Y? Is years X or years Y? X. So they're asking what is X? So in which year would you expect the population to have doubled from its 2005 level? Do we know how many deer were in 2005? How do we know, Spencer? It's on where? Is it? This is years after 2005. How could we know our 2005 deer level? It's, no, close. Y-intercept. Do we know the y-intercept? Yes, what is it? 201. Let's round to the nearest deer. So the initial in 2005, our A value is our initial amount. So 201 deer. So that would be our initial 201 deer. Pretty accurate. So we want to find when it's doubled. So how much would be double? 402. So is X equal to 402 or is Y equal to 402? Y2 is 402. Good old calculator. 402. Graph it. If you're zoomed out already, things are good. And now what? Intersect. Second trace 5. 1, 2, 3. Been doing that for 3 years. Okay. So to the nearest what? Oh, so it's 8.2 years, but what are they asking? In what year? So it's 8.2 years later. So what year would that be? In the year of 2013. Add the 8. Just add to the 2005. So in this year, early in 2013. We have field trip. Go count deer.
Where are we supposed to go?
Maybe I need to make one.
Where?
Well, there's ones for like Rexall I could put together maybe. Where you like do volume of the ice and yeah, you do estimation strategies for counting how many chairs and yeah. Okay, so maybe not. Okay, now this question. We need to listen carefully to this guy. The euphotic zone, the upper 200-meter layer of the oceans. Very little sunlight penetrates deeper than 200. So most plants live in the euphotic zone. As a result, 70% of all photosynthesis on Earth occurs in this zone. The following table gives light penetration data for the location in the Pacific Ocean. Now, it says determine the logarithmic regression. Now, what does a log graph look like? Is there going to be an asymptote horizontally at 0 or vertically at 0? Vertically at 0. Okay. vertically at 0, this is an asymptote, a line that the graph can't touch. That's an asymptote, right? A log graph usually looks either like this or like this. Okay, one or the other. So that means, is it possible to have x equals 0? No. Meaning that, who do we want to make our x? Sunlight. This has to be x and this has to be y. Else your graph, it's going to give you an error if you try to use this guy as x and this guy as y, because this will cause problems. You cannot have, in a log graph, the graph will never touch 0, x equals 0. Okay, so in a log graph, natural log, because it's always natural log of x, can you take the natural log of 0? No, it's not possible. So we're going to actually use this guy as x and this guy as y. If you want to try it, this guy is x and this guy is y, you'll run into a problem. It's going to give you error. It won't let you do it. Okay, so stat, edit. How do we clear our tables? Delete it. No. Clear. 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 Trying to. Yes, if you delete it, just reset your calculator. Yeah. Yeah, that would work too. Alrighty, so we're going to use that guy as x, 100, 54.37, 29.57, and 4.76. Did you put this guy as x? Okay. 0, 20, 40, 60, 80, 100. Okay, got an error still? Did this line up? Which type of regression did you do? No, we're doing a natural log, right? So it does take logarithmic regression. Okay, so stat, calc, I think it's number, depends on, no, it's number 9. Yeah, number 9. Bars, y, bars, enter, enter. You should get an equation. You got the same thing? Oh, okay, good. Okay, so there's my equation. And it says determine the equation. Round to the nearest hundredth. So what's the hundredth, guys? Okay, should you know what a hundredth is? 2 decimal places. If you don't, that's okay. So this is what's really important here. Okay, because 1/100, 1 divided by 100, 2 decimals. How many? Yeah, how many zeros in 100?
That's my net.
Okay.
There's 3 spots in 100, so it'd be on the second after the
2 decimals. Okay, so it is tragic if you round incorrectly on your diploma, because will you get the mark? No. And every single question is worth 1 divided by 40 times 100. So each question is worth 2.5%, meaning that each question is 1.25% of your final grade. No pressure. I'm trying to scare you, but do not lose 1.25% because you can't round. I will cry on your behalf, I promise. I will get angry and I will throw things. Okay? Check your rounding, please, on your numerical response questions. Check your rounding. Be very, very, very careful. Okay? Because they're not going to be as friendly as I am, who sometimes be like, I'll give it to you this time. Which has happened. I know. I need to get stricter with you guys. I know. Yeah. Next year for the next guys. I know. Okay, so I don't know if I've caused this problem. Guys need to know how to round. So 151.21.
What decimal places those R squared values at?
We don't, what?
On the calculator.
Right now? Oh, I don't figure that out right now. We got too much to do. Minus, what would this round to the nearest hundred? 0.84 minus 32.84 natural log of x. Okay. Using your equation, determine the depth of sunlight at 35%. So which one did they give us? X. X equals 35. So on our, how do we make our graph look pretty? Zoom, stat, which is 9. Okay. So we want the value of 35. Second trace number 1, 35, enter. It's actually, to the nearest tenth would be how many decimal places? How many zeros in 10? 1. 34.5. And that's in meters. Okay, using your equation, determine the amount of sunlight that penetrates to a depth of 200. So this time they gave us a y2. Alrighty. So y2, going back to our graph. Oops, wrong thing. 200. Hopefully we see it. If not, what are we going to do? Zoom out. Let's zoom out. It's easier. Zoom. 3. Don't forget to push enter. Sometimes you forget to push enter and you're like, why isn't it zooming? Okay, and now you can go second trace 5, do your intersect. And our value is, to the nearest hundredth, 2 decimal places, is what? 0.23%. So almost what? Almost 0, which makes sense, right? Almost no sunlight. Okay. All right, so that's it for the logs portion. Let's go over to polynomials. And then you'll have time to work. Okay, page 51.
Do this. Describe a situation where you had to break out of your comfort zone. When is that
Okay,
going to happen?
this one's really short, guys. It's not as long. Okay, page 54, or 51. 51.
Doesn't matter. Does not matter.
Okay. Each of these, it says, without graphing, determine the following characteristics of each. We're going to have to use some graphing in one of them. But that's okay. Okay, how do we figure out the number of possible x-intercepts? Looks like how do we figure that guy out? What is that equivalent to? Does anyone remember? Something. Starts with a D, ends with an E. Degree. It's equal to the degree of the function. Now, do we remember what degree is? The little number, the exponent. So, what's the exponent on this function? Yeah, so this would be degree 1. What would be the next guy? Yeah, the highest power you see, degree 2, and the last one is degree 3. So, the number of possible x-intercepts is 1. 1 possible. Okay, what would be a domain of, well, what is this graph going to look like? If it's degree 1 function, what does it look like? It's a line. Remember studying these in grade 10? mx plus b? Yeah. Okay. So this is going to be a line, a linear function. Degree 1s are always linear. And because it has a positive leading coefficient, so the leading coefficient is the coefficient in front of our degree variable. It's positive, so that means it's rising to the right. It's going to be a positive slope. So this guy, domain would be XER. In fact, all polynomial functions have domain XER. Yeah, so there's no restrictions on our x variable. Y-intercept. How do we get the y-intercept? Oops. We let who equal to 0? We let x equal to 0. It's also equivalent to our constant in the function. So who's the constant in this function? -5. So the y-intercept is -5. Okay, range of a line. What would it be? Y-E-R. Forever up, forever down. End behavior, because it's positive, it's a positive slope. It's going to go from quadrant 3 to 1. Remember 1, 2, 3, 4 for quadrants? Okay, number of possible turning points. How do we figure out the number of possible? Doesn't mean that there's that many. 1 less than the degree. So the degree minus 1. Degree minus 1. And what's a turning point? I kind of said something inappropriate. Can you remember? I sung a song. It's a hump, right? Yeah, my humps. My lovely graphing humps. I don't know. Check it out. Okay, so we're talking about lumps, right? Lumps, lovely. It's you're gonna have an increase decrease. Has to make okay. A graph like this, does it have any turning points? No, it doesn't, because it's not actually creating an up-down situation, a max or a min value. Okay, there has to be a max or a min value, a hill, so to speak. Okay, so 1 less than the degree. So how many turning points possible in a line? 0. None. Let's be a dash. Okay, so this guy who's degree 2, let's look at him. What does a degree 2 look like? We studied them in grade 11. Parabola, a quadratic, right? A U. Now, is this guy going to be opening up or down? We look at the leading coefficient. If it's negative, which way? So leading coefficient tells us which direction it'll be. So this would be down. A parabola opening downwards. Okay, if it was a positive coefficient, it would be like a happy face. So what's the number of possible x-intercepts? Julia, do you want to find a seed? Oh, can you wait outside for a second? I don't know. No, but I'll be right there. Give me 2 seconds. I don't know, because we're going on. Okay, so what's going to be the domain of this function? XER, what's going to be the y-intercept? Let's call on somebody. Ashley. 8. So it's our constant, is our y-intercept. Okay, what would be, now unfortunately, how would we get the range of this function? What would you have to figure out? You'd have to find the max. It did say without graphing. So in order to find the max, we'd actually have to factor this guy. Okay, and then, yeah, then average our x-intercepts and go on from there. So another way we could find, even though it did say this, we're going to actually use our graphing calculator here. So how could you find the maximum in your graphing calculator, just really quickly? Yeah, just go, I'll just show you here, second trace, and go to max, go to the left side of the max, right side, and make a guess, okay? So it gives you 10, and so by is less than or equal to 10 once you plug that in. Because it's a maximum and not a minimum, it's less than. Okay, what's our end behavior going to be if it's going like this? Who to who? 3, we always go to the right, left to right, like we're reading a book. So 3 to 4. quadrant 3 to quadrant 4. And last, number of possible turning points. One possible turning point. Actually, we'll have one. Okay, I'd like you to try the next one on your own, the cubic. And try to do it without graphing. Without graphing.